In today's video, we are looking at Fleming's left-hand rule. Okay, we know from previous videos, the field between these two magnetic poles looks like this. We also know that wires with currents flowing through them have a magnetic field associated with them. So, if I place my electromagnet, my piece of wire, into that permanent magnet's magnetic field, I get those two fields interacting. The interaction of those two fields together gives me a force on my wire. Don't believe me? Let me show you. Okay, so here is my supply, and I've got my electricity going through my red bit here, through this aluminium piece of foil, back through the black bit and back to my supply. So it's a complete circuit, so when I turn this on, there will be a current running through this piece of aluminium foil. My piece of foil with my current running through it is lying right between two poles of my permanent magnet. Okay, so as I've said, the magnetic field coming from the current should interact with the magnetic field from my permanent magnet, and my aluminium foil should feel a force on it. Let's see if it does. So the force on my aluminium pushes that piece of aluminium upwards. Now, what happens if I reverse the direction of my current? Now my wire feels a force, but it's in the opposite direction. To be fair, it is a great party trick. Although you do have the disadvantage of bringing all that equipment to your party. Now, this effect is greatest when the magnetic field is perpendicular to my current. Or in other words, they are at 90 degrees to each other. And depending on the direction of the magnetic field and the direction of my current, you'll get a different direction for the force acting on your wire. So, how can I determine the direction of the force on my wire? Well, I can use something called Fleming's left-hand rule. Step 1 to this rule, you need to be using your left hand. And even at this age, that simple instruction is not a given. With your left hand, you need to create this shape with your fingers so that your thumb, your first finger and your second finger are all perpendicular to each other. And these fingers all have a different quantity associated with them. Your thumb will end up showing you the direction of your force. Your first or index finger will show you the direction of your magnetic field. And your middle finger or your second finger will tell you the direction of your current. How do I remember which finger is which? Well, there's a slightly cheeky way that you can remember this. And it goes something like this. Fudge you mother fudging cupcake. Fudge you, force. You mother fudging magnetic field, cupcake, current. And just make absolutely sure that you are saying fudge you mother fudging cupcake and nothing else. Now, my top tips for using Fleming's left-hand rule are keep your fingers strong. How often do I see pupils attempting to use this rule and starting to do this with their fingers? Keep your fingers perpendicular to each other at all points. So do not move your fingers, only move your arm or your wrist, and even you can twist your body if that is helpful. Let's do an example. We place this wire into this magnetic field. What is the direction of the force on the wire? So for this one here, we have my magnetic field is from north to south. So I am going to point my first finger, which was my magnetic field, in the direction from the North Pole to the South Pole. Okay, and then my second finger, which is my current, is pointing upwards. So now I look at the direction of my thumb and it is pointing out towards the camera. So the force on this wire is out of the page. Okay, hope you found that useful. Please download the notes, Fleming's left-hand rule and some further examples. If you like the video, please do like and subscribe. Thanks for watching.